Lesson 2-6, systems of equations and three variables. Ooh, page 113. Systems of equations and three variables, page 113. In the beginning of this lesson, I want to look at big picture. What are the categories of questions that they could ask? So, like, solve a system with one solution, infinitely many solutions, no solution. Okay? And then they have word puzzles. Okay. So I want to look at big picture. What does that mean? How do you think about sort of graphically? And then I've selected a few of the main puzzles starting on page 119, and I will solve these out. Right? So some pure math looking ones, and then a couple of word puzzles. Right, so that is the plan. I suppose get wrong on here. Go back to the beginning of the chapter. So back to page 113. Okay. So we're looking for an ordered triple as the solution. So you can have an x, y, and z. Right? So instead of just an x, y, right? So there could be like uh, like in the previous chapter, maybe they were like two kinds of tickets sold. They were student tickets and adult tickets. Okay. Now maybe there's also a third variable going on. Okay. So you could set up. Now if you have three variables you're solving for, like an x, y, and a z, you do need three independent equations to solve it. So if you have one equation, one unknown, you can solve it. Two independent equations, two unknowns, you can solve it. Or three equations could match three unknowns, in this case, an x, y, and z. Um, so what does this look like? So you can use substitution, elimination, until you narrow it down to just one variable. You can solve for that variable. Then you can go back and then substitute it to the other equations and eventually work your way through. Okay. Yeah, I want to just focus on big picture here. So if you have a system with one solution, what does that sort of look like from a graph point of view? Now, as a graph, now we're opening up to three dimensions, right? So I don't just have an x-axis and a y-axis. Now you have to think in 3D. So I'll have an x, y, and a z-axis. So maybe this is my x-axis. Right? Maybe this is my y-axis. Right? So normally that's all we care about. So I'm looking at this. This would be my plane right here, my xy plane. Okay? But now we're opening up a new dimension. Okay? So about like that. Okay? Now look at these planes look like. Right. Grab some colored pencils and have a good color. So instead of lines, these will manifest as planes. Maybe got a red plane, a green plane, and a blue plane. Okay. So if you take like these expressions here that had an x, y, and a z in them. Okay. Okay. So if it was just an x, it might just be like a straight line. If it was an x and a y, it would be like a line that was like diagonal. And x, y, and z could be like a whole plane of solution. Okay. Right now, here you really got to stretch your imagination a bit. Okay. Like, what could this plane sort of look like? Okay. So maybe one of these planes looks something like this, right? It could go on and forever in all directions, but maybe it's sort of like angled like that at like so many degrees uh, from this y-axis, for example. So that you can keep on going forever this way, to the left. It could go up. It could go to the right forever, right? And it could go like sort of down forever, right? So that, but maybe it's again kind of rotated from that y-axis. Okay? Right, so that could be one expression in terms of x, y, and z. Okay? And then maybe you have like a second plane that does, maybe it's whatever the equation looks like. Maybe it looks something kind of like this. Yeah, just kind of making something up. Okay? I bet there's like some expression that could define this like 3D plane there, right? Right. Well, the plane itself is 2D, but it's in a 3D coordinate system. Maybe it's kind of like this. Okay, same thing, you can go on forever in that direction, and this direction, and this direction, and in this direction. Right? Now, if these are angled like that, do you guys see how there's like this whole line where these two planes like could cross through each other? Right? I made it in that green bold right there. Right? Now, that's not a single point. So already, we've sort of narrowed down the possibilities of like what X, Y, and Z could be, but there's a lot of possibilities. It could be that, could be that, could be that, could be that. There could be a lot of things. Right? But if we bring in one more equation to describe one more plane, so I'll draw in red. Maybe this plane is more like maybe it's going like this type direction. Okay, something like this. It's going like this, maybe something. Just kind of make something up. Okay, and again, it could go forever up. It's okay. Maybe forever to the right, um, and maybe forever down, and forever to the left. Right, so like that, right? But there would be exactly one place where this red plane I just made, right? This red plane. would cross this green line, which represents the intersection between the green plane and the blue plane. And you're right, bam, right there, right there. Right? So if you knew what coordinate that was, say, well, how far over do you go x? This could be like the x coordinate, like x, right? Okay. How far over this way do you go? Again, in terms of the, well, actually, this would be the z-axis as I made it. So oops, maybe this way to get to y, right? So this way in the y direction, so this would be like your y coordinate. Okay? And then this way back into the page to finally match to get to this point z. And this could be like how far across z, like on the z-axis. So it'd be x, y, in the back of the page z. So this could be x comma y comma z. Ooh, so it's an ordered triple. It's not an ordered pair. It's an ordered triple because there's three variables, like three variable solution to get to that point. Okay, that's sort of what it looks like in 3D. Now, that would be a system with one solution, which these usually work out to have one solution. Right. But what about infinitely many solutions? Now that would be the case of like, what if you had a like, okay, you've got three expressions, but what if two of these turn out to be the same? Right? Kind of analogous to here. You guys remember back in the plane days when we just had say like an XY plane. Okay, so X, Y. Okay. What if you had like two equations? It's like, okay, y equals mx plus b, all right, and then you draw that line. And then you have another equation and you put it into slope intercept form. And it turns out to be the exact same equation when we solve something like that. Well, these two lines would actually be the same line, so there'd be infinitely many places there, so you get infinitely many solutions. Well, okay, so I drew three like planes here in 3D space. What if it turned out that two of these were actually like the same plane? Like, what if this red one was this blue one? Well, in that case, the solution set would just be this entire green line, which would be infinitely many solutions, right? Now, it couldn't be like anything, right? Just like on a flat line, if like, suppose whenever x is 0, y is equal to 1 or whatever, right? The intercept is, right? But x could be a lot of things, y could be a lot of corresponding things, in the same similar idea over here, right? So that would be infinitely many solutions. So I bet a couple of these equations, yeah, I see which two are the same equation. Actually, it's these top two. Equation one and equation two are going to be the same thing, and I'll show you guys why. Okay, so if you look at the coefficients, so I have a negative on the x here and a 4 on the x here. See if you take this top one, you multiply by -4, gives you that thing, right? That same pattern with all these other ones. Because 5 times -4 is -20. -4 times -4 is +16. -2 times -4 is +8. Yeah, so the top two equations are the exact same equation, okay? And they could intersect with equation 3, which would itself be different, but you get like a whole array of possible answers. That's why there would be infinitely many solutions if you just go on forever. Okay. And their third category is a system with no solution. Now, I remember in a 2D plane, what would create no solution, and that's if you had parallel lines. I'll draw that to remind you guys what that looked like. So I got an x-axis, a y-axis. Okay. What if I had y equals mx plus b when I get this line? And I do different equation, y equals mx plus b. And it has the same slope, but a different y-intercept. Right? And then these two lines, since they would be parallel, they never cross, so there is no solution from a graphical point of view. Right? Well, what if in my 3D system, I got all these planes going on. Right? What if two of my planes were parallel? Well, in that case, those planes would never cross, so there would be no solution. Aha! Okay? So I bet if I map these out in 3D space, two of these planes would turn out to be parallel. I wonder if I could, at a glance, guess which ones those would be. Okay, I think I suspect it might be the first and the third. And the reason I'm thinking that is because I'm looking at the ratio of or the coefficients fronted the y and the z. Okay, you see how if you go 2 times -3 is -6, and then 1 times -3 is -3. Okay, so that's making me think that equations 1 and 3 might be parallel to each other. Now the x coefficient is different, and the solution is different. Or actually, you know what? Okay, 3 times -3 is also -9. Yeah, okay. But 19 times -3 is not 7. So yeah, in fact, equations 1 and 3 would produce parallel planes in a 3D space. Okay? That's why there would be no solution. Okay? The three planes will never intersect at a single point. Okay? Okay. And then in their example 4, they give you a word puzzle. Okay? So let's look at this just again, big picture, I think, how this could work out. Okay, so we got Dolly Museum in St. Petersburg, Florida, offered a individual, dual, and family memberships, which cost $60, $80, and $100 respectively. Suppose in 1 month the museum sells a total of 81 memberships, right, for a total of $6,420. the number of dual memberships is purchased as twice that of individual memberships. Write and solve the system of equations to determine the number of new individual memberships, dual memberships, and family memberships, which we're calling X, Y, and Z. Okay? Actually, let's go ahead and do this one. This one looks pretty fun. So X represents, so this is an example for individual memberships. Right? Y is the number of dual memberships, and Z is the number of family memberships. Okay, so we got X, Y, and Z defined. Now I know if I can make an equation out of 81 memberships. If I add together X plus Y plus Z, I know that comes out to 81 total memberships being sold. Right? I also know this. I know price value. So $60 per individual times the number of individual, plus $80 for dual times the number of dual, plus $100 for family times the number of family. That should come out to $6,420. Right? This would be so number of memberships, number of dollars. Now I do have to have one more condition to be able to solve this. Otherwise, with three variables, X, Y, and Z, and two equations, that's not enough by itself to be able to definitively know anything. And it's this detail right here. The number of dual memberships purchased is twice that of an individual. Aha, aha. So number of dual, which is like Y, is equal to twice individual. Now this is solvable. Aha. Okay. So here's my system right here. Okay. With three independent equations and three unknowns, the X, Y, and Z. So now there are many ways to solve this. I can go through elimination methods, I can go through substitution methods and various orders. So there's not like a particular like one way to do this, right? But what's the lowest hanging fruit? And the lowest hanging fruit I see is I can take y equals 2x and I can substitute into this y and also into this y right here. You do both of those, okay? Which will bring me down to two equations with two unknowns because I'm eliminating the y, right? And then that's more feasible. So let's do that. Let's bring this down here and this down here, and I'm going to rewrite these. So this is, so this equation is first. So we got x plus, now I'm not going to write y, I'm going to write 2x because that is y. So I know that. And then plus z is 81. Right, and then from this one, I got 60x plus 80, but I'm not going to write y, I'm going to write 2x because that is y. And then plus 100z, this comes out to 6420. Okay, so now I've narrowed the system down to two equations with just two unknowns. Now I only have x's and z's. Right, so let me clean this up. I think I got enough space down here to rewrite this a little bit. Like this makes 3x, so 3x, and then I still got the z. That comes out to 81. And then down here, let's see, 80 times 2 is 160, plus this 60, is that 220, I think? It's 166. I think it's 220. So it's 220, and that'd be x. And then I still have 100z. Right. And that comes out to 6420. Right, so here's my system again. All right, so I'm just doing step by step by step. Right, so I gotta continue. Notice the paper. Right. Now, how do I want to finish this off? I could use substitution or elimination. Right? Like substitution, I could solve for the z, for example. That'd be 81 minus 3x. I could sub that here and get x, and then everything else would fall like a chain of dominoes. Right? You know, I have not used elimination yet. So let me do elimination just to change it up a little bit. I could do this. I could multiply this entire top equation by negative 100. So that would be negative 300x and plus negative 100z equals, and then negative 100. Okay, see, I just took this equation and just multiplied by negative 100. Here, I'll spell that out right here. I'll do this whole thing. I'll say times negative 100. Right, but that distributes point, point, point. That's where I got all these coefficients from, right? Right. And why did I do that? Because it's going to allow me to eliminate the z's when I add it to this other equation. 220x plus 100z equals 6420. I just copy pasted that, so that's no different. So that system is still valid, right? But look at this. Oh yeah. So again, I'm honing in on I'll spell this out. Elimination. Okay. You didn't have to do it this way. You could have solved it a different way. Perfectly fine. Okay, so I'm getting, ooh, this is funny here. What is negative 300 plus 220? So it gives me negative 80x. The z's just go away. And then what is negative 8100 plus 6420? Okay. Ooh, good. So the fact that I'm getting negative, negative, that's good because the negatives cancel, which means I'll have a positive number of membership sold, which is good, right? Right. So what is 1680 divided by 80? Looks like X equals 21. So there's 21 individual memberships. I know that. Bam, I got a number on the board. Okay. Now, remember back to this condition here, y is equal to 2x. So if y is equal to 2x from before, then that's just sub in 21. That would be 42 memberships. So 42 memberships are dual. So this is individual. This is dual. I'm just reminding you guys that that's the definition of what is X, what is Y. Individual membership, dual membership. But what about family memberships? And I think the easiest way to get that is from this condition right here. I got X plus Y plus Z. Remember the total memberships was 81? Okay. You could go through the pricing system. That would be okay too. That would also get it for two. But I think this is more straightforward. So I know Y is 42. I know X is 21. So I got 21 plus 42 plus however many family memberships has to add up to 81 memberships. So take 81, subtract out 21, and 42, which is 42. Okay. I'm getting 18, and that's family memberships, 18 family memberships. Oops, there you go. I got that. Okay. So there you go. That's the answer. And so 21 individual, 42 dual, 18 family. Okay. Actually, I will use that price equation to check my answer. Okay? Make sure I didn't make any silly arithmetic mistakes along the way and so on. Okay? So that's this one right here. Remember how the sales add up to $6,400? Okay, let's try that. So let's go 60 individual, or sorry, $60 per individual for 21 of those memberships, plus $80 for 42 memberships. And then there's $100 plans for each of these 18 family memberships. Okay. Now, if everything's good, this should add up to 6420, and I know everything is correct. It sure is 6420. Oh yeah, oh yeah, we are winning. We are winning. That's what success looks like. So moving on. That's okay. That's all the examples I want to do. All right, let's dive into these questions. So again, I'm going to do these four like pure math, and then I'll do a couple of word puzzles that they got here. So let's do some pure math. Okay. Now I forget which one's which, but out of these four pure math ones I picked, I checked ahead of time, and two of these workout have solutions. One of these has infinitely many solutions, and one of these is no solution. I forget which one's which, so let's go in and see what we get. So number four, they're doing S, T, and U. Okay, S is a funny variable. Make sure you have good handwriting. You can just, so it doesn't look like a 5, right? Okay. Or I'll just call it X. How about that? I'll just call it 3X. Okay, so you don't mix up your S's and 5s. Okay, I'll leave the T as T and I'll leave the U as U. I think that's okay. Equals 5. Okay. I got 3X plus 2T minus U equals 11, and 6X minus 3T plus 2U. That adds up to negative 12. Okay, so there's my system. Okay. I bet there's probably at least a dozen different ways to solve this. All right. There's substitution methods, there's elimination methods. You could start with any one of these and hone in a lot of different ways to do this. Okay. How about this? What if what if I I see a really good way to do this. Okay. Guys, watch this. These top two equations right here. If I bring these two down, see how there's similar type coefficients on two of these variables? That means I can very quickly solve for t, right? Which would be very helpful because I can subtract one of these from the other. So I'll just copy paste the first expression. 3x minus t minus u is 5. And this next one, I'll multiply everything by -1. So I'll effectively just be negating everything. So negative 3x, then minus 2t, then plus u, right? And that would be -11. See, I just multiplied everything by -1, right? So I just took this whole thing times -1, and that distributed to all four of these terms. Then the -1 did, and that looks like this. All right. Now, I can very quickly hone in on what is t using this elimination method. Elimination method. Okay. So add these together, the x's go away. I have -3t. The u's also go away, and that leaves me with -6. Okay, so -3t is -6. Divide those sides by -3, and t is 2. All right, so we got one variable down, 2 to go. All right, we already know one of the variables, so t is 2. Okay, so now what? Well, since I used the first two equations in combination with each other, I've sort of exhausted those. So I need to bring in the third one way or another, I think. Oh, wait, hold on. No, do I still? No, yeah, I got to bring in the third one at some point. So I'll just go ahead and substitute in 2 for t. And okay, let's do that. So I'll pick these two right here. So 3x plus 2t. But I'm not going to write t. I'm just going to go ahead and sub in this 2 because I know that's the case. Top one of these dominoes right here. Minus u. Okay, so this would add up to 11. And this other one would be 6x minus 3t. But again, I'm not going to do t. I'll just call it 2 because I know it's 2. Plus 2u is -12. Okay. Okay. So now I have two equations with two unknowns. Yeah, that would be solvable. I could double the top equation and add it to the bottom. That could eliminate my u's. So let's do more elimination. Okay, so I'll do 2 times this entire top expression. So distribute, distribute, distribute that factor of 2. I'm setting it up to eliminate the u's so I can solve for x. So bring this down, and I'll also copy paste this one and bring this one down. So it gives me 6x plus, say, 2 times 2 times 2 would be 8, and then minus 2u equals 22. And then just copy paste this next one. Is 6x minus, well, 3 times 2 is 6. I'll just call it 6, right? All right, and then plus 2u equals -12. That's just there. That's the same system. Okay. Now I'm setting this up for another elimination. Elimination. Okay. Okay, so add these together. That's 12x. Now this would be plus 2 right here. 8 minus 6 is 2. The u's go away. Okay, and then this comes out to 10, doesn't it? 22 minus 12 is 10. Okay. All right, so I can solve for x right here. Solve for x. Subtract over 2. So 12x is equal to 8. Therefore, okay, divide both sides by 12. Okay, we get a fraction. So x is 8 over 12. Does that reduce to 2/3, I think, right? Over 4. Yeah. Okay, so we're getting like a fraction type answer. That's right. So x is 2/3. And so what we've got so far, we got t is 2. We got x is 2/3. Right? Well, now I should be able to take any one of these three equations, substitute in the values for t and for x, and I can just very simply solve for u. All right, so let's do that. Moving on down. How about the very first expression? So 3x, but I'm not going to say x. I'm going to say 2/3. 2/3, because x is 2/3. So in place of this x, I'm putting 2/3. Okay, plus, I also know t is 2, so I'll just leave that 2. Okay, I want to solve for this u. What is this u? Well, this has to add up to 11. Okay, so now we're down to one equation with one unknown. Okay, so 3 times 2/3. This whole bit right here is 2. This whole thing is 4 minus u. We're solving for u. Comes out to 11. Okay, 2 plus 4 is 6. Okay, what? 6 minus u equals 11. Okay, so here, okay, minus 6, minus 6. Okay, negative u equals 5, so u equals -5. And okay. All right, so now I know everything. So I got x is equal to 2/3. I got t is, what was t? I think it was 2, right? Yeah, t is 2. It's 2. And u is -5. Okay. So as an ordered triplet, it would look like this: 2/3, comma 2, comma -5. Right, and that would follow the like x, comma T comma U. They were calling it S T U. I just changed it to S. Okay. So you could also call it like that. Okay. Last thing I'm going to do on this one is check my answers. So how about an equation I haven't revisited in a while? How about this third one right here? Okay. So if I plug in this ordered triplet to these corresponding variables, it should come out to -12. Let's see if it does. If it does, we're good. So 6 times x, I call it x 2/3, so 2/3, okay, minus 3 times t, and t is 2, so put in 2, right? And then plus 2 times u, and u is -5. Aha, -5, right? Right, this should be -12. Let's see if it is. Oh yeah, that is what winning looks like. Yeah, my report. All right, let's try next one. Number 5. Okay. I think if I remember right, between 5 and 6, one of these is no solution and one of these is infinitely many solutions. And I forget which one's which, but I think we'll find out organically just by trying to solve it. So 2x minus 4y minus z equals 10. 4x minus 8y minus 2z is 16. And 3x plus y plus z equals 12. Okay. Okay, so if I like this. Okay. All right, so what should I do? You know what? I see if I add together the first and the third, I can eliminate the z. All right. How would let me think about this. All right, so strategize here. Wait, I changed my mind. Okay, I changed my mind because I noticed something kind of funny about these top two equations. So actually, let's take these top two right here. Okay. Here's what I do. I'm gonna multiply this entire top equation by -2. So I'll do times -2. And I'll do that for the whole expression. So distribute, 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 because I got these 1, 2, 3, 4 terms. And I will bring that down here. Right, and then I'll just copy paste the second expression, and something funny is about to happen. I can see it already. Right, so this would be -4x, -2 times -4 is +8, and then grab y. And then this would be negative, it's +2z. That would add up to -20. Okay, and then copy paste this one, right beneath it, 4x minus 8y minus 2z is equal to 16. Right. Now, I was setting up an elimination here. So what happens if I add these two expressions together and I try to use elimination? Right? Like I'm trying to sort of eliminate variables. Well, the x's go to 0. The y's go to 0. The z's go to 0. And this turns out to be -4. So I'm getting the statement 0 equals -4. That is a false statement. That's not even true. Okay? And I remember from past lessons how to interpret that. Okay? I remember what it was for 2 dimensions. Like if it was in 2 dimensions, okay? Like you have an x-axis and a y-axis, okay? And you got a statement like that, and you said, "Well, I wonder what the graphs look like." And you make the graphs. What that would show up as is parallel lines. Okay? You would get these parallel lines, but they would never cross, and so there would be no solution. And in fact, that's the answer. Okay? Therefore, no solution. Okay? In 3 dimensions with these 3 variables, what it means is that these top 2 expressions would be creating parallel planes, like in a 3D space. They'd be parallel planes, they would never cross. So there's no place where all 3 expressions or all 3 planes, if you think about geometrically, would ever cross at a single point. Yeah, so no solution. That's the answer to number 5. Okay. Well, if that's the case, then number 6, I think, does come out to be infinitely many solutions, which I think then also means that 2 of these expressions end up being the same. But let's see if we can do that, because I don't know which ones are which. I haven't worked this out. Okay. So P, I was just going through the teacher's guide, and I was looking for one. Okay, one that has solutions, one that comes out to no solution, and this one said, I think this one said infinitely many, if I remember right. 6q plus 4r equals 2. Okay, so we got a p, q, and an r. Okay, and then we got 2p plus 4q minus 8r equals 16. And we got p minus 2q. Well, okay, and then there is no r. That's just equal to 5. So like that. Okay. That that right. Like that here. Think what it. How should I approach this one? I don't know, but here, I'll just start playing around with it and see what happens. Okay. Let's say I take this third expression, I rearrange and solve for p. I could say p equals, so p equals, then I add over the 2q plus 2q plus 2q, okay, and that would look like 2q plus 5. And I think I can use this as a substitution. Okay? So in place of p, like here, I could substitute this p into that p and also that p right there. Right, I can do that. Okay? So I'll get it in terms of q. Okay. And then, yeah, then I would have two equations with that are in terms of q and r, right? And then I can figure out what to do from there. So let me bit. So I'll bring this down here, and I'll bring this one down here. Right? But I'm going to substitute in, instead of p, I'm going to call it 2q plus 5. Now this is p alone, so it is 2q plus 5 alone. Okay? Then I get a minus 6q, right? I get a plus 4r, this is all equal to 2. Just copy that one. Right. And this bottom one, I get 2p. But again, I'm not going to say p, I'm going to say 2q plus 5. Right. And then I got a plus 4q, and then a minus 8r. This is all equal to 16. All right. So this should be a valid set of equations here, right? Where I have now two equations and two unknowns. I got q's flying around, I got some r's. Distribute this and clean this up a bit. Okay. So here, if I had here, I think I got enough space right here where I can rewrite both of these. So 2q minus 6q, wouldn't that be negative 4q? I got a 5 in the mix and I got 4r. So I'll do plus my 4r and plus a 5. This is all equal to 2. And then down here, 2 and 2, that's 4q's, right? Plus 10. Here, maybe I'll put that over here. Right. Well, yeah, set plus 10 because that's here. Okay. Then I got another 4q here, so plus another 4q, and minus 8r. Right. And this all sums to 16. Right. So that looks a little messy. That's like kind of an intermediary step. So I have to keep going, keep cleaning this up. So rewrite this again as negative 4q. So keep this right here. Okay. Plus 4r. Maybe I could subtract over 5 and say that's equal to negative 3. Okay, that would be okay, right? Okay. This bottom one, okay, I'm getting 8q's, 8q, minus 8r. And then if I subtract over 10, wouldn't that give me positive 6? Something like that. Okay. Okay. Yeah. Okay, I see where it's headed now. Okay, so I had to play around with this a little bit because it wasn't immediately obvious, at least to me from the outset. But I see now. Okay, so guys, what happens if I double that top expression and then I add these two together to try, hey, what if I will try to eliminate the q? What if that's my goal? I'm going to spell this out. Elimination. Okay, so my goal is to sort of eliminate the q's and try to solve for r. So the way to do that is I would multiply the entire top expression by 2. So 2 times this whole top expression. Now the 2 distributes into each one of these terms, right, on both sides of the equation. It balances it. So that gives me negative 8q plus 8r equals, and then 2 times 3 is negative 6. Right? And then down here, I'll have 8q minus 8r is equal to positive 6. Okay? And then, okay, then I can add these two expressions together and I can eliminate the q's, except, well, it actually eliminates everything, doesn't it? So I'm getting the expression 0 is equal to 0 if I add everything up. That zip goes like that, zip. Okay? It's all 0 equals 0, right? Which is a true expression. Say, okay, well, that's true, okay? But I lost all my variables. So I can't really solve this. Okay? Another way to interpret this is if I were to multiply this other expression by -1, it would look exactly the same as this one. What that effectively means is that these are both the same equation. Here, I'll spell that out too. So these are the same equation. They just, well, negated, but if you multiply everything by -1, if you graph these, they would be the same like graph sort of, right? And what that means is that out of the three original equations they gave us, if I'm thinking about sort of like planes in a 3D space, okay, two of these are actually could be the same or work out the same, or in such a way that there could be not a single point where all three equations come together. So, or sorry, there would be a line. There would be a line. Okay? Even if they aren't all the same equation, which might not be the case, okay? There would be like a complete line of answers. So there would be infinitely many solutions. Yeah, in fact, I can think geometrically, like graphically, how that could be. You could have three different planes, and yet they could conspire together to not cross through a single point. Okay? So suppose I have an x-axis here. Now I could go y-axis here and z-axis here, or I could go y-axis here and z-axis. Actually, I think it's more conventional to do it like this. If I so normally we're like looking down on an XY plane that way. Can you guys imagine 3D looking down on your paper? But now let's bring a z-axis out of the paper. Maybe I should have done that before. I don't know, whatever. Same idea. Okay. Right, so what could this look like? Well, what if I had one plane? Suppose it's like sitting on the y-axis just to give you guys a visual. Maybe it's like this blue plane here. Again, it could go forever that way, and that way, and that way, and that way. So that's fine, right? And then what if I have like a green plane that's also sort of sitting on the y-axis? They could go forever that way, that way, and that way, and that way. And then where's the red guy? Okay. What if I have a third plane that's also sitting on the y-axis and it's like this? Okay, go forever that way, and that way, and that way, and that way. Okay. But see how all three of these planes align on the y-axis? Okay. So there's not like a single point where they all come together. Hence, infinitely many solutions. Okay. Now, I don't know what these three equations they gave us look like. They're probably not all sitting on the y-axis. I don't think that's the case, but it probably looks something like this. Right? There's like a single axis. Maybe it might be some weird axis in 3D space where they're all there's not a single point. Okay. All right, so let's do one more pure math example. That's number 12. Now this one I know does end up coming out to one solution. I, I don't know what that solution is yet, but it does work out with something. So I want to do at least one more of these before we get to word questions. Let's do 3x minus 2y plus 2z equals -2. Let's do an x plus 6y minus 2z equals -2. And then x plus 2y equals 0. Okay. Right, so here's your system. Again, there's many different ways to solve this: substitution, elimination, so on. Right? How about this? What if I did this gameplay? I do see if I add the top two equations together, the z's immediately eliminate, and that would be a nice option. While I'm at it, could I rearrange this bottom one and say, well, x subtract over 2y equals -2y. I could take that and I could substitute that, and for this x right here, and also this x right here, I'm going to do that. So I'll bring in the substitution, right? Because I know x is -2y from this third expression. Okay, sub that in for these x's up here, right here and here. And then later on, when I eventually add these two expressions, the top two together, it'll eliminate the z, and I'll immediately know what is y. And all the dominoes are going to fall from that point. So bring this down. We got 3x, but I'm not going to say x. I'm going to say -2y, 2y, because I'm getting it right there. Right. Minus this 2y, right, plus this 2z. Right, this adds up to this -2. Right, got that. Right, then bring this guy right here down, right beneath it. So I got x, but again, I'm not going to say x. I'm going to say -2y because I'm substituting that right there. So this also shows up there. Right, plus this 6y minus 2z equals also -2. Right? So now I have two equations with two unknowns, the y and the z. But all right, I set this up to happen too. Okay, I can do an elimination right here. I'll spell this out. Elimination. You guys see what I'm eliminating? The z's. Because if I add these together, the z's go away. Okay, so here this is negative 6y and negative 2y brings me to negative 8y. Negative 2y and 6y is positive 4y. The z's go away. And this is negative 2 is negative 4. Okay. Actually, maybe I should have added these two together already. That's negative 4y. So negative 4y equals negative 4. Therefore, y is equal to 1. Okay. So there you go. Here's the first domino. Okay. I know y is equal to 1. Okay. Well, if y is equal to 1, then what is x? I can immediately get that too. In fact, I can solve it. And here, new paper. Okay. I know x is equal to negative 2y, and I know that y is 1, so I can substitute 1 right there. Therefore, x is equal to negative 2. So there's the next domino. Okay, so I know y is 1. I know x is negative 2. Okay. All right, so now all we have to do is go to either one of these top expressions and solve for z. Maybe I pick the first one. Okay. So 3x minus 2y plus 2z. We're solving for z now. Okay. That has to add up to negative 2. Okay, that was the first one we gave us. Okay. And I know what these are. So here's my x. Substitute right there. Here's my y. Substitute right there. Boom, boom. Substitute. So 3 times negative 2 minus 2 times 1 plus 2z, we're solving for z, equals negative 2. Okay. And so this is like negative 6 minus 2 plus 2z equals negative 2. Okay, so it's like negative 8. So what if I add over 8? Add over 8. So 2z equals 6. Therefore, z equals 3. Aha. Okay. So here's my x, my y, and my z. Boom, boom, boom. Okay. Here, I'll write it in this space right here as an ordered triplet. Ordered triplet. So that'd be like x, comma, y, comma, z. Okay. So that would be like negative 2, comma, 1, comma, 3. That's my x, y, z right there. Okay. And last thing I'll do on this one is I will check my answer with the second equation. So if I plug in the values I found, x, y, and z, I should get negative 2 from this one. That's it. So x was negative 2, so negative 2. Okay. Plus 6y, plus 6 times my y was 1. And then minus 2 times z. My z came out to be 3 at the end. Okay. All right, hopefully this should be negative 2. Yeah, it sure is. Oh, yeah. Oh, yeah. Another win. All right, let's hit these word questions. Animal nutrition, number 13. Animal nutrition. That a veterinarian wants to make a food mix for guinea pigs that contains 23 grams of protein, 6.2 grams of fat, and 16 grams of moisture. The composition of 3 available mixtures are shown in the table. Okay? So we've got mix A, mix B, mix C. He goes to the store, he buys these off the shelf. He says, okay, we've got so much protein, so much fat, and so much moisture, but they're all different, right? But he wants to target these. Okay? So how many grams of each mix should he mix together? Right? So this is kind of like a recipe where I'm sure we've seen some of these before. It's like how much sugar and how much flour to put in the cake, and you got it right with like 2 variables, but this is 3 variables. So I think we can solve this if we set up some systems of equations. Right? I'm going to define x as actually no, maybe I should use p, f, and m. That's more uh, maybe more intuitive, right? So I'll call p equals protein. I'll say F equals fat and M equals moisture. Okay, so those are my variables, kind of like X, Y, and Z. Same idea, right? Okay. So what do I know here? Okay. Well, let's see, how can I set that up? No, what? I chose the wrong variables. Let me start over. Mistake. That's not my variables. My variables are A, B, and C. Right? I'm being silly. Okay. So here, start fresh here. Start over. Okay. Right, so our variables are going to be how much of mix A, how much of mix B, and how much of mix C. Yeah, that's the three variables we're going for right there. Right, that's what we're doing. We're solving for how much of each one of those. All right, so I know in terms of protein, if I do 0.2 grams of protein at times the amount for mix A, right, plus 0.1 grams of protein for the amount of mix B, plus 0.15 grams protein times the amount of mix C. Okay, that has to come out to 23 grams total. Right? The grams per mix times the amount of mix gives me the total grams. Okay, so that's protein. Okay. That's like the protein equation right there is what that is. Okay. Now the variables are how much of each mix. Okay. Then how about fat? Okay, so 0.02 of mix A plus 0.06 of mix B plus 0.10 of mix C. That has to add up to 6.2 grams of fat. And then, because that's A, B. Sorry, this is 0.5 right here. Oops, I scratched that. Just going right across. Okay, make sure I'm getting this right. So protein, 0.2, 0.1, 0.15. Yeah. Fat, 0.2, 0.06, and 0.05. This is 0.5 right here. Okay. Okay. And then moisture. Okay. Then the moisture mix. So, um, yeah. So 0.15 of mix A, uh, plus 0.10 of mix B, 0.10 of mix B, plus 0.05, yeah, of mix C. Right, this that's like that. Right. That comes out to the moisture content. I need 16 grams of moisture. Good. Okay, so there's my system. All right, so we're good. Right, there's my system right there. Just got. Okay. And so I have three equations and three unknowns. So now what? Right. Well, how about this? I see, and I'm just gonna start plugging and playing with this thing. Right? I do see if I subtract these two expressions from each other, I can eliminate C. I'll just get it in terms of A and B. Okay, that might be helpful. Yeah. Yeah. Okay. Let's see what happens then. So here, I'll just say subtract bottom, which I'll call this equation one, equation two, and equation three. So equations number two and three. Okay. So do one minus the other. Okay. So here, maybe I'll take the bottom one, subtract it. So number three minus number two. Okay. So 0.15 minus 0.02. So that gives you 0.13 mix A. Then this minus this is plus 0.04 of mix B. The C's go away. And then this minus this, 16 minus 6 is 10. So minus 0.8 is 9.8. Right. So that would be a valid expression. Okay. Let's see. And I still have to bring in the top equation somehow also. How about this? What if I solve for, let's say, B, for example, and I substitute, I use that to substitute out this B here in terms of A. I think I could do that, right? So subtract over 0.13, so 0.04 B, we're solving for B, equals 9.8 minus 0.13 A. Okay. And then if I multiply, or, well, okay, if I multiply by 25, that would just, or divide by 0.04, either way. If I multiply by 25 or divide by 0.04, it's the same thing. So distribute, distribute, distribute. Okay. So just to show you that works, 0.04 times 25 is 1. Okay. So B equals, and then what's 9.8 times 25 is 245. And then 0.13 times 25, you're getting, it's negative. So 3.25, and that's in terms of A. Okay. So I can take this expression right here, B in terms of A, and I can substitute into this top equation. So, bam, right there into that B. Okay, so I'll do that. So, and you somehow interact all three expressions. So I interacted the bottom two, and I eliminated the C variable. Okay. And now I have B in terms of A. I'll sub that to the top one, see what this looks like. So 2a plus 0.1, but instead of b, I'm going to do this whole expression. 245 minus 3.25a. And then plus 0.15c. This all comes out to 23. Something like that. Okay, so distribute this, and what's 0.1 times negative 3.25 is this, and plus 0.2. So I've consolidated all this to negative 0.125a. That's 1 over 8, by the way. Right. Then let's start like this. So plus 24.5, and then plus 0.15c equals 23. So now I can get a relationship between a and c. Right? Now, I know what is b in terms of a. So, okay, I see how I can finish this out. Now I can solve c in terms of a. And if I know b in terms of a and I know c in terms of a, I can go to one of the bottom two expressions and I can just solve for a. And then all the dominoes are going to fall from that point. Okay, so, so we're good. We're in good shape. Right, so how did I do that? Let's just take this 23, subtract it over the 24.5. So here, I'll do it this way. I got my 0.15c. We're solving for here. Okay. I'm still doing minus 0.125a. That's still part of this. Okay. That's equal to, and this minus this is negative 1.5. So add this over, 0.15c equals 0.125a minus 1.5. Okay. Divide both sides by 0.15, 0.15, 0.15. Okay, I'll get c in terms of a. So c equals 0.125 or 0.15. Ooh, that's a funny looking fraction. Is that 5/6, I think? Yeah, sure is. It's 5/6a. Okay, and then minus 1.5, 5.15, what is that? 10. Okay, so now I have c in terms of a. Ooh, okay. So we're in a good spot. We're in a good spot. Because before we know b in terms of a, and now I know c in terms of a. All right, so I can pick one of these bottom two and just substitute out the b and the c, and I can very quickly solve for a. Oh yeah, that's what we're going to do. How about equation number 2? So 0.02a, solve for a now. Okay, plus 0.06b, but I'm not going to say b, I'm going to say this right here. So 245 minus 3.25a. Okay. And then plus, yeah, I'll just continue this down here. Okay. 0.05 c, but instead of c, I'm going to say this expression right here. Okay. 5/6a minus 10. Okay. So all this adds up to 6.2. Okay. Right, so let's do distribute, 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 distribute. Try this out here. Here, I'll just do this all in the calculator and then point steps table of time here. So 0.02 of my a there, right? And then minus right here, 0.06 times 3.25 a's. And then down here, I'll do plus 0.05 times 5/6 a's. Ooh, it's a wacky little fraction. What is that times 3? It's, say, how about times 30? Yeah, negative 4 over 30. Okay. So it's negative 4 over 30 a's. Solve for a. Okay. And then the rest of this, I got negative 3.25, negative 3.25 times 0.06. Right. And then minus 10 times 0.05. Right. So that's negative 0.695. This is all equal to 6.2. So add this over. That, yeah, is that right? Oh, scratch that. That's not right. Hold on. That's okay. I got back a little bit. I was going a little too fast. Okay. 3.25. Okay. Sorry, this 245 right here. Let me go back and redo that. So 0.06 times 245, right, and then minus 0.05 times 10. Okay, yeah, this looks much better, much better. Yeah, maybe something's off. Okay, that should be 14.2. Okay, so subtract that over. So negative 4 over 30a, reduced to 2 over 15, by the way, maybe cut that, equals what, 6.2 minus 14.2 is negative 8. Yeah, looks nice. Right, and then What's 8 times 30 divided by 4? The negatives cancel. That is 60. A is 60. Okay, so next A is say 60 grams, I think. No, once 100. Yeah. Okay, okay. So 60 units. I think like 60 grams we'll call it. Okay. Right. So the first domino just fell. Ooh. Okay. And now we can very quickly get the others because remember, I know B in terms of A is this expression right here. So let's try that. What's 245? So therefore, B equals okay, got 245 minus 3.25 times A, and A is 60. So B is 50 grams. And C is, and I have an expression for C right here. So that's 5, 6A. So do 5, 6, A is 60. And then minus 10 is 40. Right. Okay. Those are really nice looking numbers. And so I bet your textbook set it up in such a way that I did not realize that was going to be so difficult to solve along the way. That took quite a bit. Actually, that wasn't too bad. Was that only 3 pages of paper? Yeah, that whole thing was only 3 pages of paper. So that wasn't actually that wasn't too bad, right? Right. So here's a review of what we just did. I had these three equations, three unknowns. I took two of them, put them in combination, and I got B in terms of A. I subbed that back into the first expression and um, and then combined it with the third expression. Okay, I was able to get C in terms of A, right? And then when you have B in terms of A and C in terms of A, you substitute out the B's and the C's, and you just solve for A. Now, once you get A, that's like the first domino. Then you can get B from this substitution, C from this substitution, and we're getting this is the final answer. Yeah, so that's the mix right there. So that looks good. Now let's do one more of these that got marked. Newspaper. A newspaper company has three printing presses that together can produce 3,500 papers each hour. The fastest printer can print 100 more than twice the number of papers of the slowest press. The two slower presses combined produce 100 more papers than the fastest press. How many newspapers can each printing press produce in an hour? Okay. So this is all, okay, so 3,500 newspapers in an hour. So I'm going to call number 19. Let's say X is like um, refers to the slowest press. So papers per hour of the slowest press. Let's call Y equals papers per hour for like the middle press and the Goldilocks press. We'll call Z the papers per hour for the fastest press. Okay, so there's our variables, and that's the question: how many newspapers can each press produce in an hour? So they want you to solve for X, Y, and Z. We just got a set of equations and solve the equations. Okay. Now I do see right away the three presses together produce 3,500 newspapers each hour. So I know X plus Y plus Z. So if I mean all their papers per hour comes out to 3,500. There's one equation. And we need to make three equations because there's three unknowns. So what else can we do? So we've got one equation. The fastest printer can print 100 more than twice the number of papers of the slowest press. Okay. So twice the number of papers of the slowest press, that's like 2x. And then 100 more than that, that's like plus 100. Okay. And then that is equal to the fastest printer, which is printer Z. Okay. So now I have a second equation. Okay. Now I still need one more equation. This is not solvable yet without one more piece of information. Oh, is this one right here? The two slower presses combined, now the slowest ones is x plus y. So x plus y combined, that's x and y combined. What does it say about x and y combined? Can produce 100 more papers than the fastest press. So that's equal to whatever the fastest press did. If you add 100 to that, that's the two slowest combined. Yeah, so that right there is my system. There's my system. Okay. And that's half the fun right there. It's just figuring out how to translate this word puzzle into mathematical looking equations. Right? All right, and the second half of this fun is going to how do you solve this? Right? Well, let's see. How would I solve this? Uh, Guys, look at this, look at this, look at this. Right? If I subtract the first two expressions from each other, so I'll call this like expression one, expression two, expression three. Okay. So if I do expression number 1 minus expression number 3. Right? If I do this minus this, watch what happens. The x's and the y's go away, and I can immediately solve for z. Once I get z, I can get x, and once I have z and x, I can get y. Boom, boom, boom. Right? I see the whole chain of dominoes lined up. Yeah, it's all good. Here, let's break out a new paper for this one. So expression 1 is x plus y plus z is 3,500. Expression 3 is x plus y, right? Is it okay if I subtract over z, like minus z? Okay, and that's equal to 100 right there. Okay, now I want to subtract off this bottom one. So if I subtract, can I just distribute this negative into all 4 terms? Go negative, negative, positive, negative, and then go and then add these two together. It's the same thing. Okay, the x's, goodbye, y's, goodbye. I have 2z equals 3,400. So divided by 2, z is 1,700. Okay. So that should be the fastest press. The fastest press is doing 1,700 papers an hour. Okay, so this is papers per hour. If you wanted a unit on that, right, which would be a good idea. Right, now I know I can find x from the second expression because I know 2x plus 100 equals z, and z is that 1,700 right there. So subtract 100. So 2x, we're solving for x, equals 1,600. Therefore, x equals 800. Boom! There's my slowest press. And that would be papers per hour. Yeah, and you guys see how the slowest press is not printing as many as the fastest press. That makes sense too. We just got to chase down y. How about this bottom expression? So I know x plus y equals z plus 100. So x plus y equals z plus 100. Right, that was my equation number 3, if you like. Okay. And I know what x and z are. So in place of x, I'll put 800. It goes right there. Now I don't know y. I'm still trying to solve for y. And in place of z, I'll put right there, 1,700. And then plus this 100 for the equation. Okay. So 1,700 and 100 is 1,800 minus 800. Y is 1,000. That's papers per hour. Papers per hour. Okay. And remember from the outset, we defined y as like the middle press, like it was faster than the slowest and slower than the fastest. So on and above. Yeah, look at that. It can produce more papers than the slowest press and not as many papers as the fastest press. So I think that's the answer right there. And as an order triplet, it'd be like 800, 1,000, 1,700. That's my like x, comma, y, comma, z order triplet right there. Okay. Last thing I'll do with this one is check my answer. Those are nice looking numbers, so that's almost certainly the answer. I'll check it with the first expression. It should add up to 3,500 papers an hour. I have not checked that in a while, so let's see. What is 1,700 here, plus 800 here, plus 1,000 here? Okay, this should add up to 3,500. If it does, then we can call this lesson a wrap. Oh yeah, oh yeah, look at that, 3,500. So we are good. Oh yeah.